So today we're going to take notes on balanced and unbalanced forces. This is objective 7.P.1.2. We have talked about this objective before. It covers Newton's laws, but we only looked at this objective from Newton's laws standpoint. What are the three laws, and could we identify those three laws present in when we did, cartoons and things like that? Now we're going to focus on what balanced and unbalanced forces are. So the essential question we're trying to answer is, how do these balanced and unbalanced forces affect the motion of an object? And to do that, we need to understand what inertia is, and this definition is very scientific. I'm going to break it down and make it simple for you. So inertia is the resistance of any physical object to any change in its state of motion. So inertia is how something can or cannot change its motion. It includes a change in its speed and direction. So in science, with this law of inertia and trying to figure out, we need to talk about what is a force. So when we talk about it in science, it's either a push or a pull. All forces have two properties: what direction and what size is the force. The unit of measure we're going to use for this is called a Newton. Came from Sir Isaac Newton, and we're going to use a capital N as our abbreviation for that unit, and it really describes the size of the force. Okay, here's an example. The student is pushing down on the chair, but the chair does not move. The floor is balancing the force by pushing up on the chair. I'm going to show you a picture of that. Okay, so you can see right here, the boy is pushing down on the chair is pushing back up. These forces are balanced, which means the chair is not moving and neither is the person. Okay, those are balanced forces. We can combine forces to show an overall net force. So more than one force often acts on an object. All right, sometimes those are in the same direction, sometimes they're not. We're going to investigate both. When all the forces acting on an object are added together, you determine the net force on the object. An object with a net force of more than 0 newtons will change its state of motion. So if I even have a net force of 0.1 newtons, that object is in motion because it is acting on an unbalanced force. When the forces are applied in the same direction, you add them up, and I'm going to show you lots of examples of this. All right, so if the forces are both moving in the same direction, you add them together. If they're moving in opposite directions, we'll subtract them, and I'll talk about that. So two people are moving a piano. So she is pushing the piano with a net force of 25. He is pulling the piano with a force of 20. Together, they are pulling and pushing that with a net force of 45 newtons to the right, if we're using it in relevance of the picture. Because 25 plus 20 equals 45. And what direction is that piano moving? It's moving in the direction of the push and the pull. What happens if they're moving in opposite directions, like a tug of war? Okay, when two forces act in different directions, you actually subtract the two. You subtract the smaller one from the larger one to determine the net force. The net force will be in the same direction as the bigger force. All right, and I'll explain that with the tug of war with the dogs there in a moment. Okay, so this dog is pulling with a net force of 10 newtons. This dog is pulling in the opposite direction with a net force of 12 newtons. The combined net force here is 2 newtons towards the dog on the right because he is pulling with more force than this dog, so therefore the rope will actually start to move and these dogs will start to back up. Sometimes forces are balanced. All right, when that is the case, we get a net force of 0. All right, the object is not moving, it's not changing direction, it's a 0 force. There is no change in the motion. Okay, so for example, this little cartoon man is standing there. All right, gravity is pulling him down. The floor is pushing back up. If he is just standing there, not in motion, those net forces equal 0. Okay, unbalanced forces. Sometimes they're not balanced. They do become unbalanced. Okay, this is what we call when the net force is greater than 0. Okay, those are unbalanced. When the net force is 0, balanced. Okay, unbalanced forces produce a change in the motion of the object. So for example, our boy's in the canoe, and I apologize that my screen is covering this up here. So this boy right here is pulling the canoe with 70 newtons to the left. This boy right here is pushing the canoe with 90 newtons to the left. So we get a combined total force, net force of 160 newtons to the left, which will eventually get this boat in the water. So there are 4 practice problems on your paper right now. I'm going to give you time. What I would do is pause the movie because you want to go over you want to answer those 4 practice problems and then go ahead and continue playing the movie because I'm going to show you the answers. So in problem number 1, the net force is 350 newtons to the right. Number 2, the net force is 200 newtons up. Number 3, the net force equals 0. And in number 4, the net force is 30 newtons to the left. So gravity, mass, and distance. All right, gravity is the force of attraction between matter. All right, there's gravity holding us on our planet. There's gravity holding the moon close to us. There's gravity holding the earth in its position that it is around the sun. Gravity depends on really your mass and how far you are from that gravitational pull. The more massive an object, the more it can attract objects to itself. Okay, so things with a larger mass will take more gravity or have more gravity pulling them down. The further away an object gets from one another, the less gravitational attraction can be found. Okay, so as we move further and further and further away from the sun, if we were to do that, the less gravitational pull the sun would have on us. All right, magnets are another force that can be described here in this objective. Okay, so a magnet is an object with a north and south pole that produces a magnetic field and exerts a force. All right, we've all used magnets before. I have them on my fridge. I have them on the board behind me. All right, a magnetic field is the force field that surrounds the magnet. A magnetic force can cause objects to attract, come together, or repel, move apart, without needing to touch the magnet. So how do magnets affect motion? Like poles, so on a magnet you have a north and a south pole. If I have 2 north poles, they don't like each other, all right, because they're the same. They will actually repel or move away from each other. Opposite poles attract, and if you can remember the phrase opposites attract when it comes to a magnet, that'll help you. Okay, so here is a picture of a magnet. When we have opposite poles, they are attracted to each other. When we have like poles, they will repel. And the reason they do this is the magnetic field coming off this end of the magnet is the same as this magnetic field. There's no desire to be attracted because they're the same. They want to be attracted to things that are different. How do we use a magnet in everyday lives? Compass is a perfect example, and you have that on your paper there describing a compass. All right, because Earth has a magnetic field, a force field coming off of the north and south pole, you can actually use a compass that magnetically will point towards the North Pole. So you can know all the time with a compass what direction is north.